Alright, in this video we're going to look at solving systems of equations using substitution. So we learned graphing, where you can graph using slope-intercept form and see where two lines intersect. Now we're going to look at another method when you're given two equations, and a method of solving them is using systems with substitution. So title today's note, solve systems using substitution. Make sure you put today's date in either corner. So it's a quick word that we need to define, which is substitute. So substitute just means to replace. You're going to replace with something else. So when we have systems of equations and we're going to use substitution, you're going to see two equations. Let's jump right into the examples for today's video. A system is when you have two or more equations. So here are my two equations. Y equals 4 and 4x plus 2y equals 16. All right. Before we would graph these equations, but with this graph, or this set of equations, this isn't set up to be graphed right away. So we can use another method that's called substitution. And what tells me to do substitution is that I have one of the variables, y, that's solved for already, which means the y is all by itself, and it's just equal to one other thing. So in this case, y is equal to 4. So what that's telling me is that I can take this value for y and substitute it in for y in the other equation. Because if y equals 4, well then in the other equation, and I'll just rewrite it out, I can replace the y with 4. And now I can do some steps to get the x by itself and solve for x. So I put the 4 in parentheses because we substituted it in and it's next to a number. So we replace the y value with 4, and now I can do 2 times 4 is 8. And now I can just solve this equation for x. So subtract 8 on both sides. 4x equals 8. Divide by 4. X equals 2. So the solution to this system of equations is 2, 4. When I plug in 2 for x and plug in 4 for y, it makes the solution, it makes both equations true. Let's take a look at a little bit harder of an example. Okay, so let's say I gave you this as our system of equations. Y equals x plus 7 and negative 5x plus 2y equals 17. So again, when I look at the system of equations, I know I'm not going to be graphing because both lines aren't set up where I could graph them easily. The first equation is set up as slope-intercept form, but this one is in standard form, so I can't from this form right away go into graphing. So then I look, are one of the variables solved for, which means are one of the variables all by themselves. And in this case, again, we have y all by itself. What I'm going to do is I'm going to box the whole thing that y is equal to, because now this is what I'm going to replace for y in the other equation. If y equals x plus 7, then I can take this whole thing and plug it in for y. So I'll rewrite my equation. And I'm going to replace this whole value for the y, because we said y equals. So the 2 is still in front. And then now I'm going to put in parentheses. I'm going to plug in the whole thing inside of that box. So negative 5x plus 2 parentheses x plus 7. And now we can solve with methods that we've learned. So I just distributed the 2 to the inside the parentheses. Combining like terms, we've got negative 3x plus 14 equals 17. And now I can subtract 14 on both sides and get negative 3x equals 3. Divide by negative 3, x equals negative 1. We're not done with this problem though, because all we found so far was the x value. So now I'm going to take what I found for x and plug it in to the other equation. So y equals negative 1 plus 7. So y equals 6. So the solution here is negative 1 comma 6. So when I plug in negative 1 for x and 6 for y, it'll make both of these equations true. That's solving using substitution. All right, let's look at one more example. We have 2x plus 3y equal to 16, and x equal to 2y minus 6. So here's my system of equations. I have a little bracket which links the equations together. So looking at these equations, these aren't set up to be solved by graphing, and they're not, because neither of them are actually solved for y. So now I'm looking for the variable that's all alone by itself, and that happens to be the x in this case. So I'm going to put a box around what x equals, and I'm going to plug it in for x in the other equation. I'm going to start off with the other equation. I'm going to replace x with parentheses. And now I can distribute, combine like terms, and solve for y this time. So 4y and 3y's are 7y's. I can move the 12 over here and get 7y equal to 28. So I combined like terms, 4y plus 3y is 7y. And then I consolidated by bringing the 12 over to both sides. And now I divide both sides by 7 and get my y value is equal to 4, because 28 divided by 7 is 4. But I'm not done. I found my y value, but I don't know what x equals. So I start off with that second equation. Since x is already by itself, I'm going to plug in y is 4. So 2 times 4 is 8. 8 minus 6 is 2. So the solution for this set, remember your solutions are always x comma y, is 2 comma 4. So when I plug in 2 for x and 4 for y, that'll make each of these equations true. And that's solving using substitution.